Welcome to this course on Cooper-Beeline seismic bracing. In this second lesson on basics of seismic bracing, we will look at the features and applications of various types of bracing. Before we get started, let's review what we will be covering in this lesson. By the end of this lesson, you should be able to explain why seismic bracing is necessary, differentiate between lateral and longitudinal bracing, differentiate between rigid and cable bracing, and explain features, benefits, and applications of both. A common question asked by contractors in the field is, why use seismic bracing? Here are some reasons why seismic bracing is important. Many building codes address seismic bracing. For example, the International Building Code, IBC, which references the American Society of Civil Engineers, ASCE 7, and the National Fire Protection Association 13, NFPA 13, have made seismic bracing a requirement. Typically, 50% or more of monetary damage after an earthquake is from the failure of non-structural components. We've learned from historical earthquakes that seismic bracing helps protect buildings and their mechanical, electrical, plumbing, and fire sprinkler systems, otherwise known as MEP systems. Also, often risk mitigation or insurance companies drive the seismic bracing requirements. FM Global. Bracing is designed to keep a building's non-structural systems, such as pipe, air duct, or cable tray, moving with the building structure during an earthquake. In order to accomplish this, bracing is required in two horizontal directions: across or perpendicular to a run, and along or parallel to a run. Seismic bracing also addresses vertical movement of non-structural systems during an earthquake by strengthening the hanger assembly at the brace location. A minimum of 2 rod stiffeners are used to accomplish this, typically with Cooper-Beeline B22 strut. Rod stiffeners are required only at the seismic brace location, not at every hanger location. Tolco brand bracing products are designed to brace only non-structural systems, such as electrical, plumbing, heating, air conditioning, and fire sprinklers. If asked to brace the building structure, we do not offer this type of product. Bracing of the structure should be addressed by the structural engineer of record on any project. Here is a diagram of a lateral or transverse brace. Lateral, transverse braces prevent movement perpendicular to the pipe as shown, for cable tray, air duct, conduit, or other non-structural systems. Here is a diagram of a longitudinal brace. The longitudinal braces prevent axial movement parallel to the pipe as shown, for cable tray, air duct, conduit, or other non-structural systems. There are 2 types of bracing, rigid and cable. We'll look at both types of bracing in detail in the screens that follow. Rigid bracing works in both tension and compression. This is advantageous because it only requires 1 brace assembly per brace location. This saves cost in both time and material. One limitation of rigid bracing is the allowable length. Since it works in compression, braces can buckle if they become too long. Cable bracing works in tension only, so it requires 2 opposing brace assemblies at each brace location. This is more expensive but required in only 2 cases. 1. You may have guessed the first, since rigid bracing is limited in length. If a very long brace is required, cable may become the only option. 2. If vibration isolation is installed, cable bracing is required. Vibrations will travel through rigid bracing and will therefore defeat any benefits of a vibration isolation system. A rigid brace is the preferred type of seismic brace. It uses solid brace material that resists force and tension and compression. Let's look at the advantages and limitations of rigid bracing. The advantages of rigid bracing are: it is more economical and easier to install versus cable bracing because it only has 1 direction or 1 structural attachment due to its nature of resisting force in both tension and compression. It helps decrease material and labor costs versus cable bracing. A variety of Tolco brand sway brace products are available with break-off bolts for visual verification of proper installation and inspection of bolts, nuts that have specific torque requirements. The main limitation of rigid bracing is the length of the brace. The maximum length for a rigid brace using Cooper B-Line B22 strut is 9 feet 6 inches. A brace length of 9 foot 6 inches will cover 95% of bracing applications. Rigid bracing cannot be used in combination with vibration isolation systems. Vibration isolation is only required in a few instances in specific areas where equipment is supported. This section features the main components of Cooper B-Line Tolco rigid seismic bracing, along with examples of their installation. Universal Swivel Sway Brace Attachment, Figure 980. This is a transitional attachment of a rigid seismic brace assembly, designed to attach the brace member to the structural attachment. We call it universal because it will work with various types of rigid brace material. Besides the typical Cooper B-Line B22 strut, pipe or conduit may also be used, as well as angle iron or any type of structural steel that does not exceed 1/4 inch thickness. Fast Attach Seismic Brace Attachment, Figure 981. This is the system attachment component of a rigid brace assembly, designed to attach the brace member to the system being braced. It also has the same universal properties as the Figure 980. It will fit the same types of brace material, strut, pipe, or conduit as the Figure 980, and is designed to attach to the hanger rod. The Figure 981 comes in two sizes. Small size, fits 3/8 inch to 5/8 inch rod. Large size, fits 3/4 inch to 7/8 inch rod. This product can be attached either to single-hung pipe or conduit, or to trapeze-style hangers supporting multiple pipes, conduits, cable tray, duct, or equipment. This type of brace prevents movement perpendicular to the pipe. This type of brace prevents movement perpendicular to the pipe. In this example, the Figure 980 is used with pipe as the brace member in a typical lateral brace configuration, used with fire sprinkler systems. The Figure 1000 is used as the system attachment in this example because NFPA 13 requires that the system attachment attach directly to the pipe. The Figure 825 is also shown as the structural attachment to the bar joist above. Tolco Figure 1000 Fast Clamp. This is a system attachment component used in fire sprinkler systems. Its function is to attach Schedule 40 pipe as the brace pipe directly to the pipe being braced. Its advantage is that it allows much flexibility to the length of the brace pipe, which means that installers can be very rough in their estimate of brace pipe length. It allows a fast installation, often referred to as rough-in. Tolco Figure 825, Bar Joist Sway Brace Attachment. This is a structural attachment component of a seismic bracing assembly. It is designed to allow the attachment of a transitional fitting to a bar joist, also known as a steel truss. This is a typical type of structural member like I-beams or girders. The design allows a quick installation using 2 break-off bolts for visual verification of proper installation torque. The transitional fitting, typically Figure 980 mentioned earlier, is then attached to the third bolt with a nut provided. Tolco Figure 825A, Bar Joist Sway Brace Attachment. This product does the same work as the Figure 825, but allows only about half the load. It is a less expensive option when bracing less of a load to the same type of structural member. This type of brace prevents movement perpendicular to the pipe. In this example, the Figure 980 is paired with the Figure 4L as the system attachment rather than the Figure 981. All longitudinal attachments must attach directly to the pipe. This type of brace prevents axial movement parallel to the pipe. This type of brace prevents axial movement parallel to the pipe. In instances where rigid bracing cannot be utilized, such as the need for longer brace lengths or where vibration isolation is installed, cable bracing can be used as an alternative option. For a cable brace, since it works in tension only, 2 seismic brace assemblies are required at each brace location. In comparison to rigid bracing, there is an increased cost for both material and labor, but in some cases it is the only choice available. As in rigid bracing, Tolco cable bracing products are also available with break-off nuts for visual verification of proper installation and inspection of bolts and nuts which have torque requirements. The components are available for 3 cable sizes: 1/8 inch, 3/16 inch, and 1/4 inch. The larger the cable diameter, the greater the load capacity. This section features the main components of Cooper B-Line Tolco cable seismic bracing, along with examples of their installation. Cable sway brace attachment, Figure 990. Our cable seismic bracing attachments are designed to make installing cable easy. Cable can be very difficult to work with in the field. It frays easily when cut and can be very difficult if required to thread through thimbles or cable clips, as most of our competition's components require. Our design allows a wide opening for even severely frayed cable to easily pass through, and the visual verification of breakaway nuts helps to ensure proper installation torque every time, without the need for a torque wrench on the job site. Fast Attach Cable Sway Brace Attachment, Figure 991. This is the system attachment component of a cable seismic brace assembly. It has the same features on the cable attachment side as the Figure 990 just discussed, and it has the same features as the Figure 981 earlier discussed that allows it to be attached to various sized all-thread rod. For each cable size, the Fast Attach Cable Seismic Brace Attachment comes in 2 sizes: the small size to fit 3/8 inch to 5/8 inch hanger rod, and the large size to fit 3/4 inch through 7/8 inch rod size. This type of brace prevents movement perpendicular to the pipe. This type of brace prevents movement perpendicular to the pipe. You have come to the end of Lesson 2, Basics of Seismic Bracing. Let's review what we have covered in this lesson. You should now be able to explain why seismic bracing is necessary, differentiate between lateral and longitudinal bracing, differentiate between rigid and cable bracing, and explain the features, benefits, and applications of both.